Okay, today, guys, we're talking about errors. These are conclusions that researchers make through the hypothesis testing procedure that, through no fault of their own, is a mistake. So, the first type of error that we're going to talk about is called a type 1 error. A type 1 error occurs when the researcher rejects the null hypothesis when it's actually true. So I have a picture here of a normal curve, and it's a right shaded region. So a right-tailed region. So this would be the null hypothesis is like mu equals a value, and we are testing the alternative hypothesis that mu is greater than that value. So we shade the right tail. The alpha level is here on the right. Let's say that alpha level is 0.05. We're going to reject the null hypothesis anytime our test statistic falls in this critical region. So in other words, we're going to make a type 1 error anytime our p-value is less than alpha. So the type 1 error probability is actually the alpha level. So anytime you have an alpha of 0.05, there's a 5% chance that you're going to reject the null when it's actually true. And that's what a type 1 error says. A type 2 error is when you do not reject the null hypothesis, but it's actually false. This one's a little bit trickier because here is our original graph. And again, if we're testing a right tail, we shaded this red right tail area. Maybe that's 0.05, the alpha level. But if you make a type 2 error, you're actually saying that the mean or the proportion, whatever you're hypothesizing about, the null hypothesis, is not true. So that means the location of that hypothesis is moving. So if this is the theoretical hypothesized new mean, then when we didn't reject using the old curve, when the new mean actually moved, that's going to be the area of a type 2 error. So we're shifting this whole curve up or down. If we're testing a right tail, usually it's shifting in that same direction. So we shifted it up. And then this would be the area, this blue area is where we did not reject when we did the test, but it actually is not true. The null hypothesis is actually changing. We won't be finding those probabilities, guys, but we do need to know that the symbol that we use for the probability of a type 2 is beta. All right, here is just a visual of what can happen when you do a hypothesis test. So if the null hypothesis is true and you do not reject it, in other words, accept, we don't like to use the word accept, but here it's okay, accept the null, you've made a correct conclusion, so that's all good. But if the null hypothesis is true and you reject it, that's when you make a type 1 error. And then the other case is if the null hypothesis is false and you do not reject it, you've made an incorrect decision. That's a type 2 error. And then if the null hypothesis is false and you do reject it, you make a correct conclusion. So we can see that because we're basing our decisions off of probability, there's always a chance that we're going to be making an incorrect decision. Okay, this is just a little joke. So found this on the internet, thought it was funny. So a type 1 error is basically a false positive. And then the type 2 error is the false negative. Okay, so a little bit of humor to lighten our Tuesday. All right, so what we're going to have to do, guys, is we're going to have to take a statement. We're going to have to be able to write the null and alternative hypothesis from it. Hopefully we're comfortable there. We've been doing that for a little bit now. But then we're going to have to write a sentence of what would the type 1 error say and what would the type 2 error say. Okay, so let's first take a look at this first example. A researcher claims that adult hogs fed a special diet will be heavier than hogs not on the special diet. Hogs not on this diet weigh an average of 200 pounds. Okay, so our null hypothesis in this case would be mu equals 200. So if the diet makes no difference, we expect the hogs to weigh 200 pounds. If the diet does work, we expect that this diet will make the hogs heavier, so greater than 200. The researcher is going to conclude that the hogs are heavier when they're actually not. Okay, and then the type 2 error, we do not reject the null when it's actually false. So a type 2 error is going to say the researcher concludes that the diet didn't have an effect on the hog's weight when it actually did increase their weight. Okay, so these two sentences, guys, is what I'm going to be asking you to write during the lesson today. Just what would a type 1 error say and what would a type 2 error say? Let's look at another example. Okay, here's another example of writing a type 1 and type 2 error. This example says, test the claim that the average commute time one way is 25.4 minutes. Okay, in this case, the null hypothesis, if nothing's changing, we expect that the mean is going to take 25.4 minutes to commute to work. The alternative hypothesis, we don't have any direction stated, so this would be one where we're just saying that that value is changing in some way. I really don't know if it's increasing or decreasing. It's just not equal to 25.4. So this would be a two-tailed test. Okay, if we think about what the type 1 error means, we reject the hoe when the hoe is true. So that type 1 error is going to say the researcher concludes that the average commute time is not 25.4 minutes when it actually is. And then the type 2 error is we do not reject the null hypothesis when it's false. In this case, the researcher concludes that the average commute time is 25.4 minutes when it's actually different. Okay, guys, the third example is the you try. So take a look at this next example, pause the video, see if you can write the ho, the ha, the type 1 and type 2 errors, and then unpause the video to get the solutions. Okay, in this case, the null hypothesis would say P equals 0.25. We're hypothesizing about a proportion, so we want to use the P instead of the symbol for the mean, mu. The alternative hypothesis, P is less than 0.25. The type 1 error in this case, the researcher concludes that less than 25% of lawyers advertise when actually a higher percentage does. And then the type 2, the researcher concludes that the percentage of lawyers that advertise is 25% when the percentage is actually less. Okay, guys, this concludes the lesson for today. Post in the discussion if you have any questions.